All right, let's start with what I wanted to talk about in today's stream, which was the important points to explain. Because I have an exam coming up in 2 days, and just kind of testing myself. I'm not an expert in this field, but like you guys can correct me in the comments or help me. I don't know if there's even someone gonna watch this stream, but it's fine. It's gonna be a short stream of me just revising, and maybe this is the first time where I record and then try to upload it on YouTube. All right, we should start. The exam is about Docker containers, Kubernetes. Can't even say it. Kubernetes and or Kates, and the last one was yeah, it was just general cloud computing stuff. I was just stopping because I looked outside the window. It seems like it started snowing. God damn! What's it? It's the 2nd of November. All right. There's some rain, but it looks like snow. Anyways. The first thing I wanted to talk about was the NIST cloud model. I basically took what I needed to learn and only took some of the headlines, trying to explain without looking at it. But you gotta trust me, like I'm not looking at it. Let's grab a sip of water before we start. Did a test recording. If this doesn't work, then I'm gonna be really sad. Still recording, right? Let's just check how much disk space do I have. Oh, it seems like fine. Hold on. First note. How do I go back to? Okay, edit and live. Anyways, yeah. At first, when we talked about this, I'm gonna start with cloud computing in general. Well, why do we need cloud computing? One would say, I would just say we're gonna go through those points as well. But in most cases, it's a bit cheaper for people to start with, and you don't need to take care of computers in general. And we're gonna go through that right now. Like the essential characteristics of cloud computing are, there's this NIST principle, NIST cloud model summary, and that's the National Institute of Standards and Technologies, just a group of people that decided to create a standard that people gotta. There's also a standard for Docker containers, which we're gonna look at later on. Containers in general. Well, the NIST decided to create the essential characteristics, service model, and the deployment. The essential characteristics are broad network access, on-demand self-service, measured service. Then it was measured service, the rapid elasticity, and the resource pool. What do we mean by that? Broad network access has got to be available. Rapid elasticity, that's just a weird way of saying we gotta be able to quickly upgrade and maintain our stuff. Measured service, it's measured, of course. Like sometimes or oftentimes you pay by the hour. You only pay for the amount that you need. On-demand self-service, that's and resource pool. And we're often, when we talk about cloud computing, we have these service models. Software as a service is one, platform as a service, and infrastructure as a service. You could imagine software as a service be an email client where you just send an email to someone else and you don't care about how that email actually gets there and how the backend is built up. All you care of is that when you hit the send button, that it gets sent over to the other person. That's basically software as a service. And cloud computing is mostly built up of terms like, I don't care what's happening in the background. At least it's being sent and doing stuff. The next one is platform as a service. Oh yeah, and software as a service, a good example with Microsoft Office 365 or 365. Platform as a service is the next one. That's essentially what Heroku does. But in terms of going back to my example, it would be that you get the environment ready to develop, but you don't need to take care of all the lower level stuff like the drivers for your connection and stuff like that. You only need to program, and that's it. You don't care about how that stuff works and what operating system it's running on. You only get the platform that it runs on. And Heroku is a prime example for this, which allows you to take dynamically published web pages and host it on there. I would also say Vercel as well. Yeah. Another, and the one that basically covers everything is infrastructure as a service. You only get the infrastructure, so you can get to choose which hardware, which operating system it's running on, but where that's located and how that's being managed, you don't care about that. You only care about that it's available at all times. And a prime example would be Azure. I hope that I'm saying it right and I'm not embarrassing myself. Microsoft Azure. Yeah, I had discussions with a friend of mine in the car, and he was saying, "Oh, that's the way to say it," but we're just gonna skip over it. Two different models would be backend as a service. I would say that's super base, where you just upload your application on there, or you use the API and you don't care what it does and what it's hosted on in the background. You just use it. And functions as a service is a new one. Vercelos also offers. It's just functions that trigger based on events. Yeah. Then the next one that the NIST model finds is the deployment models. You could have a public cloud, a private cloud, a hybrid cloud, or a community cloud. And that doesn't mean that there's, when that doesn't mean the location, it means actually who's it for. So if you have a private cloud, essentially made specifically for that organization. Private cloud, private cloud. And the public cloud, something like Azure, AWS. The reference architecture, yeah, so there was like a picture of them showing us like an old picture. I don't know, reference architecture, maybe we can find it quickly. Reference picture. Cloud. Like an old picture. Yeah, that's the picture. So, can I open it up in app? Yeah, so you would have the cloud carrier here, which handles all the connection of every part of here. But the cloud provider would be something that we talked about, like AWS, that provides all of the infrastructure as a service, platform as a service, and software as a service. And then we have the cloud broker. That's basically our resellers that just take what's there and just sell it, or just build a product based on top of these service models, sell it. Then the cloud consumer would be just their customers, and the cloud auditor would be someone that audits stuff, of course, like security audits, privacy audits, and so on and so forth. Then we have this one, the open group cube model. The cube model, it makes our cloud more secure, and there's just 4 ways of, let's look at it. It's the 4 ways of how to make a cloud more secure. You would have 4 dimensions. You have the physical location of the data, which could be internal or external. And you would have the ownership, which could be proprietary or open. The security boundaries, which is like the firewall, parameterized or parameterized. And then the sourcing, sourced or outsourced. As far as I know, the goal of any provider is to go to this side. That's all I know. I'm not an expert, I'm just studying. Cloud management interfaces. You would have interfaces that do stuff for you, like the AWS public API. And that there's also other standards for those interfaces, which would be CDMI, OCCI, and CIMI. So CDMI would be cloud data management interface. We have OCI, Open Cloud Computing Interface, and the Cloud Interface, Cloud Infrastructure Management Interface. No idea what this is. Sometimes you just gotta learn stuff and accept it as it is. So CDMI, OCCI, and CIMI. What are the advantages of using public cloud providers like AWS? Of course, low barrier for entry, outsourced IT management, low barrier entry cost, of utilization, quality of service, of course, and it's simple to upgrade and maintain, do maintenance and stuff like that. What are some public cloud disadvantages? Of course, you could have lag, you could have law issues, because if you are living in Austria, just like I am, and then you basically get a server in America, there's different laws in America than here, US than here, which could lead to compliance issues or privacy, data law problems. And it could happen that you become dependent on your provider and that you can never leave, and they keep increasing the prices. There's a top 10 security issues. I'm just gonna quickly name 5. 3. I got 3, that's it. Infrastructure security, that's just, the infrastructure security of our cloud could be terrible. Then we have tenancy. That means that when we use a cloud, we don't want our data to mix up with other people's data so that something doesn't get revealed by accident. Then we need to have a fair bit of amount of logging, just analysis and forensics, user analysis and forensics data. Oftentimes when your cloud provider gets breached, you don't get the data. Like, you don't get the data, and it ends up becoming your fault. Put this here so that I know if my mic's even working. All right. And that was number 3. There was more, but I don't remember. It's a bit too much. But yeah, of course, user privacy and secondary usage of data. Yeah. How could I forget? And there's also the OWASP, Cloud Native Application Security. We could have insecure cloud, we could have workflow problems, like Git pipelines could be bad, improper authentication authorization, use of third-party libraries that are just deprecated, ineffective logging and monitoring, insecure secret storage, injection flaws, bad configuration overall of containers, stuff like that. I could put this screen. Where was I? Here. Then we have base technologies in cloud providing. We could have the platform server virtualization, load balancing, then software development, networking, and software development storage, which just enables stuff. Yeah. Let's get to something else. That was like the boring stuff. Let's get to containers and Kubernetes. Let's start with containers. What's the difference between a container and a virtual machine? Now, a virtual machine would be more resource intensive, because maybe we could find an image here as well. Container. Yeah. So there's not a problem, but it's just not scalable that much like containers, because for every single, you have a hypervisor that manages the communication between your OS and this OS. Do you have different operating systems? Virtual machines don't share the kernel. There's kernel-based virtual machines, but let's not talk about that anymore. We have different kernels, different kernels within these, but the difference is that inside containers we share the same kernels. Yeah, that's Hey Krabs, you're a bit quiet. I wanted to find the difference between containers and virtual machines. Like I said, um there's essentially here a kernel everywhere because it's a separate operating system. But here we have the container engine and we share the same kernel. And we have the same functionalities, like we can still communicate between these containers, like no problem. But yeah, just another namespace. Yeah, we're gonna talk about that actually. Good point. So we have Docker terms. Of course, the container is an isolated workspace inside the same operating system. A container image is a ready-to-use software package, you could say, that just has everything pre-configured for you. And we have the container engine. The container engine is just a piece of software again that controls or creates mount points, metadata, and then passes it over to the container runtime, which is a part of the container engine, and that just instantiates our objects. And we have the container host, which is our operating system, of course. Yeah, registry, repository, and tag. You could imagine registry being a database, a repository being like a GitHub repository, and in there we have different images with different tags, which are just versions. Like, oh, I hit my headset. But like Krabs said, we have control groups and namespace, kernel namespaces. Now, the best way to describe it without being too complicated is that control groups control how much or limit how much I can use on resources, CPU, network, disk space, and stuff like that. And kernel namespace limit how much I can see and therefore use. That's like the great definition, I think. Yeah, and the kernel namespaces are part of the Unix kernel and just isolate your workspace from your operating system. What are some container engine responsibilities and runtime responsibilities? Well, you could say that the engine responsibilities are, for example, like I said, creating the mount point metadata, preparing it and passing it over to the container engine, and that instantiates, starts, stops, and creates that workflow for us. The Open Container Initiative is the next thing I wanted to talk about. It's kind of like the National Institute of Standards and Technology, but just for containers. And there's just standards that you have to follow. There's the runtime specification and the image specification. Runtime specification is how can I make this piece of software run, or piece of this, let's say, container image run. And their image specification is we want to have some sense of usage. Like we want to be able to start, stop, transform, and all the other operations between containers. And we have Open Container Initiative compatible runtimes such as crun or runc, runc, and yeah, and other ones. Let's talk about container engines. What container engines are there? It's basically Docker. The most, like, I would say like the most popular one is Docker. It's not daemonless. It actually has a daemon job and stuff like that. It runs in the background and maintains stuff. But the alternative for Red Hat based distribution is called Podman. And it's like daemonless and allows even to create for non-root users to instantiate containers. And we have on Kubernetes or just K8s, we have this cryo. I just call it cryo, but the container runtime interface. Well, if you want to run Docker containers, you gotta use something called a Docker file. That Docker file comes with commands that it just runs when you just instantiate or build image. And what does it come with? It comes with the command from. So basically from image, and it can copy stuff over like directories. Then we have the run command that runs containers inside a new layer. And the command is the default command that gets run every time that we start our container, and expose is for ports. Let's say we have a web server and then we expose the port 80. I accidentally skipped the container image layers right there. Well, you could imagine a container being built of a lot of read-only layers, and on top of that we have a layer that's writable, and the read-only layers, let's say on the bottom we have our operating system, and we have a bunch of layers that simulate our images, and the right layer is so that we can communicate with our Docker container. Now let's say that we want to modify a file that comes from our image. Well, instead of actually, if we wanted to persist data, we're going to get into that as well. We just copy the file or the folder from the read-only layer into our write layer, and then just modify it there, and that's also known as copy on write. It just copies on write, and that's it. Yeah, let's look at the default container networks before we get to storage. The default container networks modes would be bridge, also known as port publishing, none, host. Well, bridge, let's say bridge allows for egress network address translation and ingress port forwarding on the host interface. So yeah, you get access to the host interface when you get a different IP address. Like you can communicate with your host system. None just allows for loopback addresses. Host basically allows the container to see this all the what's it called? Yeah, all the interfaces that the host interface sees. Mac VLAN is interesting because you have your host interface, and from that host interface you create a sub interface, and you get your own MAC address and IP address. But it requires that your interface is in permissions mode. I think it's pronounced permissions. If I'm wrong, just correct me. And the next one is IP VLAN, which is built kind of like Mac VLAN, but Mac VLAN, IP VLAN actually allows the sub interfaces to have the same MAC address. Why would we need that? Well, if we have a switch, we have a limited amount of ports, number of ports, and it would allow then for switches to know where to redirect the package to. If there's the same MAC address, we wouldn't have any problems. The last one is this SLIRP, Slurp for NetNS. I don't know how to say it. It's just the default network mode that comes with Podman when you instantiate or create a new container that was from a non-root user. Let's get to managing data, application data, and mount types. Well, there's three kinds. We have tempfs, bind, and volume. Tempfs is kind of just memory. It's quick, but as soon as we stop the container, it's gone, or destroy the container, it's gone. Then we have a bind, which is just any folder inside our host system, and volume, which allows for our volumes to be stored somewhere in a folder as well. But in terms of that, we have two differences. We have the named volumes and the anonymous volumes. Now, the named volumes are explicitly created. The anonymous volumes are implicitly created, and the volumes can be used by multiple containers at the same time. Okay, yeah, let's look at Kate's. What benefits comes with it? Well, Docker was used to create microservices, and inside a Docker container, you have control groups, namespaces, and a union file system, basically. Yeah, and you use Kubernetes to just or K8s to just maintain or make sure that everything's running. And there's a lot of stuff that comes out of the box with using K8s. We're gonna get to that as well, which is automatic rollouts, resource pooling management, config management, securing secrets, auto scaling, and load balancing, self healing. That's it. Now we have the components as well. Like here on K8s, it's the container runtime environment, like we said. Then that's Cryo. Then we have the container network interface, which allows for plugins to be installed on the network, and then container storage interface. The concept of K8s would be for a cluster, you would have cluster uh, inside a cluster you would have a master PC. Let's just say it's a virtual machine, and nodes which are workers. Now the nodes or the master and workers have different components on them. The master or the control plane, like the mothership which controls everything, it comes with a scheduler, an API server, a key value store, like it's called etcd, and the last one was I think that's it. I oftentimes forget about one thing, but yeah, that's fine. And the workers come with Qblood, which is like an agent. So when everything breaks down, which is pretty cool, it communicates back to the control plane. Inside the scheduler, we look up the desired state inside etcd, and then inside the scheduler, we schedule on where we're gonna get it back up and running, basically. Then we have the kube proxy, which allows for network communication between the nodes, and yeah, that's it. And also, it's an interface where we send our stuff to from from our control plane to our nodes workers. And of course, we have the container runtime as well inside our workers, and we have inside our workers something known as pods. Now, pods are just a lot of containers at once. And pods have a different IP address, nodes have a different IP address, and the control plane has its own IP address. So you gotta keep control of that, which we'll get into as well. Something also, now we configured Docker with Docker files. How can we configure our K8s? Like we want to have a certain amount of replicas and stuff like that. Well, we do that through Kubernetes objects, which are just YAML or JSON files, which define what the application is, the desired state, and there's the actual state and the desired state, and we're trying to make the desired state a bit more, let's say, available as much as possible. That's called the record of intent. Well, also what resources are available to those applications and which policies do they have to follow. What are the required information inside a YAML file? Well, the API version, the spec, the kind, which could be deployment, pod, or service. Then metadata and spec. Then we have the pod objects. Like I said, a pod just consists of multiple Docker containers. It encapsulates applications. Also, we could say on a pod we have a web server that runs, but the Docker containers itself can also be called microservices. Yeah. Container starts resources and network identity, which can both be shared between containers. All containers of a pod run on the same node. The thing is, that's the kind. So we had API version, kind, metadata, and spec. And here the kind is defined as a pod. And on controller object, instead, it's not called deployment object, it's called controller object because it's maintained on the deployed on the control plane. It's called controller objects. And here we define the deployment and the amount of replicas. So we have, let's say, a web server, and we say we want 3 replicas. We get to have, if 3 instances are not running, we immediately try to self-heal and make it run so that the desired state is achieved again. The types of control objects are deployment, daemon set, and jobs. Deployment, like I said, make sure that it runs, daemon set run in the background, and jobs run something on a cycle based. And the last one are service objects, which could be described as something that runs as a network service. You would want to have users or DNS servers only know one IP address outside, even though that like I said, every node has its own IP address, every pod has its own IP address. So you would want to group everything up and create a single IP address that people can ping on. Now there's different types of these. The main one is the cluster IP, where we just focus on the cluster IP, the single IP, the node port. Like we could ping any cluster up, and then just have a random port that works. Then we have the load balancer that, yeah, the load balancer that exposes. So you would have a cloud provider come in and handle the load balancer for you. So we have cluster IP, node port, load balancer, and the external name, which is interesting. Like it's a DNS record. So you have a CNAME record that handles, and so that we know what we're talking about, even though we search for something else. Storage, and the last thing, storage on Kubernetes is called K8s storage. On containers, you would have a problem that when the container lifetime ends, that data is gone. And here we have on the level of pods, we have ephemeral storage, which ends when the pod's lifetime is gone. But the data between pods can be shared with various types: empty directory, config map, and secret. On the cluster lifecycle level, we have persistent volumes. Persistent volumes are just defined types of storage that we want to use. And if we want a node to use a persistent volume, they need to ask for it, and that's called persistent volume claim. And then it's attached to the pod. Oh my god, that was so much. Anyways, if you're watching on YouTube, thanks so much for tuning in, and I hope you have a wonderful day.